our group will present a rare urban water pollution issue in the Klang River around Shah, focusing on the solid waste accumulation and city runoff pollution. This is not just about an ugly river, it is about flood risks, ecosystem damage, public health concerns, and rising clean-up costs. In highly urbanized areas, rivers collect what city produce, trash, sediments, or radius, and sometimes wastewater leaks. In the Klang River, solid waste can clog flow pathway, trap more debris, and reduce the river's capacity to carry stormwater, which increases the chance of flash floodings during heavy rains. What makes this case important is that the pollution is multi-source. It comes from streets, grand commercial areas, small workshop, construction site, and sometimes illegal dumping. So our approach is an integrated solution, meaning we combine engineering measures, policies and enforcement, and nature-based treatment strength with AI-supported monitoring. One approach alone is not enough because
we categorize the causes into physical, chemical, and biological pollution. Physical pollution is the most visible, which is plastic waste, bulky items, packaging, and sometimes the construction debris. These materials increase turbidity and suspended solid, reduce flow efficiency, and create blockage that trap more pollutants. Chemical pollution often comes from urban runoff, especially after rain, water flow over roads and parking area carrying oil and grease, detergents and other residues into drainage system and then into the river. This can increase COD and BOD and degrade water quality. Biological pollution can occur when there are wastewater leaks, misconnected pipes, or overflow events. This increases the risk of pathogens such as E. coli, which can create public health risk when communities are exposed. The impacts are not limited to the river itself. Environmental impacts, which is higher organic loads, can reduce dissolved oxygen and harm aquatic life, lowering biodiversity also. Social impacts, which is bad odor, poor aesthetic, and reduced recreational value, affect quality of life. Economic impacts, which is clean up operations and expensive, and flooding, can damage homes, roads, and business. Health impacts, when biological pollution is present, waterborne disease rates increase for people who live near the river or come into contact with contaminated water. So our goal is not only to make it look clean, but reduce pollution at the source and strengthen the river system.
our engineering strategy follows three actions: capture, treat, and monitor. First, trash capture and removal. We propose installing floating trash, booms, and trash traps at strategic points such as major drain outlets and river junctions. This prevents waste from spreading downstream and makes collection easier. However, the key design requirement is maintenance. The system needs a fixed schedule, safe access for workers, and a clear disposal process. Otherwise, the boom becomes a storage area. Second, stormwater treatment trains at hotspots. We recommend a sequence such as gross pollutant trap (GPT) for large debris, sedimentation or filtration units to reduce suspended solids, and also oil water separators near workshop zones and high traffic areas to capture oil and grease. This treatment train approach works because urban runoff contains mixed. Third, real-time monitoring. We propose a small network of sensors measuring turbidity, conductivity, flow rate, and also selected water quality proxies. When abnormal spikes occur, the system generates alert so response teams can investigate quickly. This shifts river management from reactive cleanups to early detection and fast response.
Engineering solutions reduce the pollution load, but policy determines whether the problem keeps repeating. Our policy package has 4 elements. 1. Hotspot enforcement. Identify illegal dumping hotspots and high-risk drain outlets. Then implement consistent inspections and penalties. Enforcement must be predictable, not occasional. Number 2, mandatory waste management practices for high-risk activities such as construction sites and certain premises. This includes proper storage, scheduled waste collection, and proof of disposal. The aim is to reduce convenient dumping. Number 3, accountability through monitoring and reporting. For high-risk premises, require basic compliance, records or periodic checks aligned with local guidelines. This improves traceability and discourages repeated violations. Number 4 is community engagement and reporting. Create an easy reporting channel and provide response updates. When the public sees real action, reporting increases and illegal dumping becomes harder to hide. Policy makes the system sustainable because it targets behavior and incentives, not only symptoms.
Now we need the nature-based solution because urban river need long-term resilience. One, not just mechanical clean-up. Nature-based solution 1, riparian buffer zone and riverbank restoration, planting and restoring vegetation along riverbank help filter sediments, slow runoff, stabilize banks and reduce erosions. This improves water quality and reduce sediment loads during storm. Nature-based solution 2, constructed wetland or biowalls near major outlets. This acts as natural polishing system, reducing suspend solid and nutrient before water enter the river. They also support biodiversity and improve the local environment. For the required AI element, we propose 3 practical use. 1. Anomaly detection. AI model can flag unusual spike from sensor data such as sudden turbidity or conductivity change. 2. Hotspot predictions. Using rainfall data, complaint history and location pattern, AI can predict where dumping or pollution spikes are more likely, helping teams prioritize patrol. 3. Option computer vision. Camera at known dumping point can detect suspicious activity or large object disposal and trigger alert. This support SDG 11, sustainable cities and communities, safer, more resilient urban living and reduced flood impact. To evaluate, we compare solutions using effectiveness, feasibility, cost sustainability, and compliance. Trash capture deliver fast, visible, result treatment train, reduce runoff, pollution at hotspot, sensor and AI improve early detection and response. Policy enforcement prevent repeat behavior. Nature-based solutions strengthen long-term river health. In conclusion, improving the Klang River in Shah requires a system approach combining engineering, policy, and ecological restoration, supported by data and AI for smarter decision. Thank you.